Imagine this for a moment. While you're calmly sitting, watching this video, something inside your body is already changing, and not in a good way. In the next few minutes, you're going to learn what actually happens inside your body when you sit for too long, why even 45 minutes can start affecting your arteries, and how a simple, almost effortless habit can protect your health for life. Before we go further, make sure you subscribe to the channel and turn on the bell icon so you never miss videos that can genuinely improve your health and understanding of your body. Now here's something most people have never been told. If you've been sitting for more than 45 minutes, the blood flow in one of the major arteries in your body, the femoral artery, which supplies your legs, has already decreased. And this isn't because your heart is getting tired or pumping less. The real reason is far more subtle and far more important. The blood vessel itself has changed. Inside every artery, there is a thin layer of cells, just one cell thick, that controls how wide or narrow the vessel is. After about 45 minutes of uninterrupted sitting, these cells reduce the production of a key molecule responsible for keeping your arteries open. As a result, the artery begins to slightly constrict. That means your blood is now moving through a narrower pathway, and it's flowing more slowly. And the most surprising part, you don't feel it. There's no pain, no warning, no obvious sign. This process begins quietly, long before your body gives you any signal. Right now, if you've been sitting for a while, this is already happening inside your legs. But here's where it gets interesting and also hopeful. This change is not permanent. If you simply stand up and move for about 5 minutes, your blood flow returns to normal. The artery relaxes again and everything resets. But the moment you sit back down and stay still, the same cycle starts again. It repeats over and over every single day. So the real question isn't whether this happens. It does. The real question is why it happens so quickly. To understand that, we need to talk about something you've probably never heard of, even though it might be the most important organ in your body. Inside every blood vessel, every artery, every vein, every tiny capillary, there is a continuous layer of cells lining the inner surface. This layer is called the endothelium. It's incredibly thin, almost impossible to notice, and it doesn't show up on the typical diagrams you see in textbooks. But its role is absolutely critical. If you could somehow remove all of these cells from your body and spread them out flat, they would cover an area of around 5,000 square meters. That's roughly the size of a football field. In terms of surface area, this makes the endothelium one of the largest organs in your entire body, even larger than your skin. And unlike what most people assume, it's not just a passive lining, it's highly active. It constantly produces substances that control how your blood flows, how your vessels expand or contract, how your blood clots, and how your body manages inflammation. In other words, this hidden organ is quietly regulating some of the most important processes that keep you alive. Yet almost no one talks about it. No one points to it on a chart. You don't feel it working. You can't see it. But every major cardiovascular problem, heart attacks, strokes, blocked arteries, begins with something going wrong in this very layer. This invisible system is what stands between you and the most common cause of death worldwide. And what keeps this system working properly is something incredibly simple: the movement of your blood. Every time you move, even slightly, your blood flows faster through your vessels. That movement creates a gentle friction along the walls of your arteries. This friction sends a signal to the endothelial cells, telling them to stay active, to produce protective molecules, and to keep your arteries open and healthy. But when you sit still for too long, that signal disappears. The blood slows down. The friction decreases, and the cells begin to change their behavior. The system that was designed to protect you starts to switch off. And this is where the real story begins. To understand what happens next, we need to focus on a single molecule. One of the most important substances your body produces, yet one most people have never heard of. This molecule is called nitric oxide, and it plays a central role in keeping your arteries healthy. Nitric oxide is produced by the endothelial cells lining your blood vessels. Its main job is simple but powerful. It tells your arteries to relax. When nitric oxide is released, the muscles in the artery wall loosen, the vessel widens, and blood flows more easily. This reduces the pressure your heart has to work against and ensures that oxygen and nutrients reach your tissues efficiently. But nitric oxide doesn't just control blood flow. It also protects your arteries. It prevents inflammation, stops harmful immune cells from sticking to the vessel walls, and reduces the chances of blood clots forming. In a way, this one molecule acts like a guardian for your entire vascular system. Now here's the key detail. Your body doesn't produce nitric oxide constantly on its own. It needs a trigger. And that trigger is something called shear stress. Shear stress is the friction created when blood flows across the inner surface of your blood vessels. When blood moves at a normal, healthy speed, this friction gently presses against the endothelial cells. The cells respond to this mechanical force by activating an enzyme that produces nitric oxide. So every time your blood flows properly, your arteries receive a signal to stay open, flexible, and protected. Think about what happens when you walk. Each step you take activates your leg muscles, especially your calf muscles. These muscles push blood through your arteries, increasing its speed. As the blood moves faster, it creates more friction along the vessel walls. The endothelial cells feel this and immediately respond by producing nitric oxide. This is how your body is designed to function. Movement creates flow, flow creates friction, and friction activates protection. Now compare that to what happens when you sit still. When you're sitting, especially for long periods, your leg muscles are inactive. The calf muscles, which normally help push blood upward, are no longer doing their job. As a result, blood flow slows down significantly, and when blood slows down, shear stress drops. Once shear stress falls below a certain level, the signal to produce nitric oxide weakens. The endothelial cells reduce their activity. Nitric oxide levels drop, and the artery begins to constrict. At the same time, the protective effects disappear. Inflammation is no longer suppressed. The vessel becomes more vulnerable, and all of this starts happening quietly, without any noticeable symptoms. This is the hidden shift that occurs every time you sit for too long. Researchers have actually measured how quickly this change happens. In one of the most direct studies on this topic, scientists observed the function of the femoral artery. The main artery supplying the legs during prolonged sitting. They used a technique called flow-mediated dilation, which measures how well an artery can expand in response to increased blood flow. It's considered one of the most reliable ways to assess endothelial health. The results of the study were quite surprising. After just 1 hour of continuous sitting, the artery's ability to dilate was reduced by nearly 50%. That means the vessel had lost half of its capacity to respond properly. Even more concerning, the decline started early. Changes were already noticeable within the first 30 minutes, and after a few hours, the damage didn't continue to worsen. It simply stayed at that reduced level until movement resumed. So within 1 hour, your arteries shift into a less functional, less protected state. But once again, there's an important detail that changes everything. When participants in the study stood up and walked for just 5 minutes every 30 minutes, this decline was completely prevented. The arteries maintained their normal function. Nitric oxide production stayed active. The protective system remained intact. 5 minutes of light movement was enough. No intense exercise, no complicated routine, just standing and walking briefly. This tells us something very important. The issue is not sitting itself, it's sitting without interruption. Every uninterrupted sitting period longer than 45 minutes creates a temporary state where your arteries are less responsive, less protected, and more vulnerable. And every time you stand and move, even briefly, you reverse that state. Now think about your typical day. If you sit for 2 hours watching something without getting up, your arteries spend most of that time in a reduced state. If you then stand for a few minutes and sit again for another long stretch, the cycle starts all over again. The pattern repeats throughout the day. So the real concern isn't just how much you sit, it's how long you sit without a break. And while this vascular effect is already significant, it's only one part of the story. Because there's another system in your body, one that controls how fat is cleared from your blood. That is also directly affected by whether your muscles are active or not. And this system responds even more dramatically to sitting. Now let's shift to another system inside your body, one that most people assume is controlled only by diet. but is actually heavily influenced by whether you're moving or sitting still. This system is responsible for clearing fat from your bloodstream, and at the center of it is a powerful enzyme called lipoprotein lipase, or LPL. LPL lives on the walls of the tiny blood vessels in your muscles. Its job is to break down triglycerides, fat molecules circulating in your blood, into smaller components that your muscles can use for energy. In simple terms, it's one of the key mechanisms your body uses to clean fat out of your bloodstream. Now here's the critical part. This enzyme does not stay active automatically. It depends on muscle activity. When your muscles contract, even at a low level, LPL remains active. It continues doing its job, clearing triglycerides and helping regulate fat metabolism. But when your muscles become inactive, like they do during prolonged sitting, LPL activity drops rapidly. This change happens remarkably fast, and not just a little. Research has shown that within just a few hours of inactivity, LPL activity in skeletal muscle can decrease by up to 90%. That's a sharp drop within the same day. It means that when you sit for long periods, your ability to clear fat from your blood is significantly reduced. Triglycerides begin to accumulate, increasing cardiovascular risk. Most people think metabolism is all about energy, how much you eat versus how much you burn. But this pathway is about whether your muscles are active or inactive. Just standing is enough to keep LPL functioning. It's a mechanical effect. Standing engages your muscles and keeps them bearing weight, which maintains vital enzyme activity. So your body isn't just tracking calories, it's tracking movement. To clear fat efficiently, don't just watch your diet. Remember to stand up and move. And just like before, the trigger isn't always what you eat. It's whether you're sitting. Now let's move to the third system, one that directly affects your energy levels, your metabolism, and your long-term risk of diseases like diabetes. This system controls how your body handles blood sugar. And just like the others, it depends heavily on whether your muscles are active or not. Your skeletal muscles are responsible for clearing the majority of glucose from your bloodstream, around 80% of it. After you eat, your blood sugar rises and your body releases insulin to help move that glucose into your muscle cells where it can be used for energy. But here's something most people don't realize. There are actually two separate signals that help move glucose into your muscles. The first is insulin. The second is muscle contraction. When your muscles contract, even during light activity, they activate a transport system that moves glucose from your blood into the muscle cells. This system is called GLUT4. It acts like a gateway, allowing sugar to enter the cells efficiently. So in a normal active state, your body uses both signals together, insulin and muscle contraction, to regulate blood sugar. Now think about what happens when you sit. When you're sitting still, the contraction signal disappears. Your muscles are inactive, so they're no longer helping move glucose out of your bloodstream. That means your body is forced to rely entirely on insulin to do the job. At first this works, but it's not efficient. Without the help of muscle contraction, your muscles become less responsive to insulin. The same amount of insulin now has a weaker effect. To compensate, your body produces more insulin to achieve the same result. Over time, this leads to what we call insulin resistance. And this isn't something that takes years to begin. It starts much sooner than most people expect. In a controlled study, researchers found that simply interrupting sitting with short, light walking breaks, just 2 minutes every 20 minutes, reduced blood sugar and insulin levels after meals by around 24 to 30% compared to continuous sitting. Same meal, same person, same insulin production. The only difference was whether the person stood up and moved regularly. That means your body's ability to process sugar can change dramatically based on something as simple as whether you stayed seated or got up for a few minutes. Now think about how this applies to everyday life. If you eat a meal and then sit for the next 2 or 3 hours, watching TV, working, scrolling, your body is trying to manage that glucose using only one signal, insulin. The muscles are not helping. But if you stand up and move briefly every 30 minutes, even lightly, your muscles contribute to the process. Both signals are active. Glucose is cleared more efficiently. Insulin levels stay lower. This difference may seem small in the moment, but over time, it adds up. If your doctor has ever mentioned rising blood sugar, borderline HbA1c, or early insulin resistance, the conversation probably focused on diet or medication. And while those are important, There's another factor that often gets overlooked: how long you sit without moving. Because your body was never designed to rely on insulin alone. It was designed to use movement as part of the system. When you remove movement, you remove half of the mechanism, and your body has to compensate. Now step back and look at what we've uncovered so far. 3 completely different systems in your body: your blood vessels, your fat metabolism, and your blood sugar regulation. They are all affected by one simple behavior: sitting without interruption. When you sit too long, your arteries begin to constrict. The enzyme that clears fat from your blood shuts down, and your muscles stop helping regulate blood sugar. 3 separate pathways, 3 different consequences, all triggered by the same thing. And the timing is what makes this even more important. These changes don't take weeks or months to develop. They begin within the first hour of uninterrupted sitting. Your endothelial function starts to decline within 30 minutes. Your fat-clearing enzymes drop within hours. Your insulin sensitivity begins to decrease during the same sitting period, and yet all of this can be reversed within minutes. Standing up, walking briefly, activating your muscles again. That's all it takes to restore the system. This tells us something very clear about how the human body is designed. It expects movement. Not intense exercise all the time, but regular low-level activity throughout the day. Sitting itself isn't the problem. It's sitting for too long without a break. There's another system, more mechanical, that explains why your legs are the first to feel it. It has to do with how blood returns to your heart, and it relies on something most people don't realize. They have a second pump, and when you sit, that pump shuts off. That second pump is not in your chest, it's in your legs. More specifically, it's in your calf muscles, and its role is absolutely essential for keeping your blood moving properly. Here's how it works. Blood traveling through your arteries is pushed by the heart with strong pressure. But once that blood enters the veins, the pressure is much lower. The body needs another way to push it back up toward the heart, especially from the legs, where it has to move against gravity. That's where your calf muscles come in. Every time you walk or shift your weight, your calf muscles contract. They squeeze the deep veins, pushing blood upward. Inside these veins are one-way valves that ensure the blood keeps moving in the right direction toward your heart. This system is known as the calf muscle pump, and it's responsible for returning a large portion of your blood circulation. Now imagine what happens when you sit. Your legs are still, your muscles are relaxed, the calf pump stops working. Without that pumping action, blood begins to pool in the veins of your lower legs. It slows down and starts to accumulate. As it builds up, the pressure inside those veins increases dramatically, from around 25 millimeters of mercury up to 90. That's more than 3 times higher. This pressure forces fluid out of your blood vessels and into the surrounding tissue. That's why your legs and ankles may swell after long periods of sitting, like during a long car ride or flight. But the effects go deeper. The walls of your veins begin to stretch. The cells lining those veins are now exposed to abnormal forces. Instead of the healthy friction created by flowing blood, they experience stretching and distortion. This triggers inflammation. At the same time, the slow-moving blood becomes more likely to clot. This brings us to a critical medical concept. This is known in medicine as Virchow's triad, the 3 main factors that increase the risk of blood clots. Prolonged sitting creates 3 dangerous conditions: slow blood flow, vein wall damage, and blood that clots more easily. This is known as Virchow's triad, and it's why sitting is strongly linked to deep vein thrombosis, or DVT. You felt it after a long flight: heavy legs, swollen ankles, and stiffness. That's blood pooling in your legs instead of returning to your heart. But there's a simple solution: your calf muscle pump. Walking contracts these muscles, pushing blood upward and resetting the system. However, when you stay still, your arterial health shifts. Endothelial cells stop protecting your vessels and start attracting immune cells to the artery wall. Keep moving to keep your circulation and your heart healthy. Now add another layer to this process. As blood flow slows and the endothelial function declines, the balance inside the vessel shifts toward oxidative stress. Reactive oxygen species begin to accumulate. These molecules interact with LDL cholesterol, the type often referred to as bad cholesterol. and convert it into an oxidized form. This oxidized LDL is particularly harmful. Once it forms, it becomes trapped beneath the endothelial layer. The immune cells that were attracted earlier now move into the vessel wall and begin consuming this oxidized LDL. As they do, they transform into what are called foam cells. These foam cells accumulate over time, forming the earliest visible signs of atherosclerosis, fatty streaks along the inner walls of the artery. This is how the process begins, not with a sudden blockage, not with years of buildup alone, but with a shift in the behavior of the endothelial cells caused by reduced blood flow. This is the part that changes how we understand cardiovascular disease. It's not just about how much cholesterol is in your blood. It's about whether your arteries are in a state that allows that cholesterol to enter and accumulate. If shear stress is high, if blood is flowing properly, the endothelium remains protective. It resists inflammation, prevents adhesion, and blocks the entry of harmful particles. But when shear stress drops, as it does during prolonged sitting, that protection weakens. The artery becomes vulnerable. And this vulnerability doesn't require years to begin. It can start within the same time frame we've been discussing, within an hour of uninterrupted sitting. Now zoom out from the microscopic level to the bigger picture. Atherosclerosis is the underlying cause of heart attacks and strokes. It is the leading cause of death worldwide. And what we're seeing here is that one of the triggers for this process is not just diet, not just genetics, but something far more common: prolonged sitting. This doesn't mean sitting is the only cause. It's not. But it is a factor that operates repeatedly every single day, often without awareness. And that makes it powerful, because every time you sit for longer than 45 minutes without moving, you're creating a temporary environment where your arteries are less protected and more open to damage. Now let's look at what happens at the population level. In a study involving over 17,000 individuals, researchers found that those who sat the most had a significantly higher risk of death. What makes this finding particularly important is that it was independent of exercise. Even people who exercise regularly still showed increased risk if they spent long periods sitting. They assume that going to the gym cancels out the effects of sitting, but the science shows that these are two separate processes. Exercise builds fitness, but the damage from sitting happens in real time. It begins within minutes and resets only when you stand and move. That means a workout in the morning does not protect you from sitting continuously in the afternoon. Each long sitting period is its own event. Each one creates its own temporary risk, and each one needs to be interrupted. Now here's where the comparison becomes difficult for many people to accept. The increased risk associated with prolonged sitting, especially more than 6 hours a day, has been shown in some studies to be comparable in scale to the risk associated with smoking. Not identical in mechanism, but similar in overall impact on mortality. And the reason this feels uncomfortable is because sitting doesn't feel dangerous. It feels normal. It feels harmless. It feels like the absence of activity, not the presence of risk. But your body doesn't interpret it that way. Your endothelium doesn't care whether you chose to sit or had to sit. It responds only to the physical conditions: blood flow, shear stress, muscle activity. When those signals drop, the system shifts. Now here's the important part. The solution is not to eliminate sitting completely. That's unrealistic in modern life. The solution is to interrupt it. The research consistently points to a simple pattern. After about 30 to 60 minutes of sitting, you need a short break. Around 5 minutes of standing or light walking is enough to restore blood flow, reactivate your muscles, and reset the systems we've discussed. This is not exercise in the traditional sense. You don't need to sweat. You don't need to push yourself. You just need to move, stand up, walk a little, shift your weight, let your muscles engage again. That's enough to bring your body back into its protective state. And when you repeat this pattern throughout the day, you maintain that protection continuously. Think about what this looks like in real life. You're watching something. Stand up when it ends. You're working. Take a short break every 30 to 45 minutes. You're reading. Pause, walk a few steps, then continue. The activity itself doesn't need to stop. Only the sitting needs to be interrupted. This small change creates a consistent flow of movement throughout your day. And that flow is exactly what your body was designed for. When you look at all the systems together, the arteries, the enzymes, the glucose transporters, they all respond to the same signal: movement. And they all begin to fail when that signal is removed. This is why the 45-minute rule matters, not as a suggestion, not as a trend, but as a reflection of how your body actually works. Your body expects regular movement. It tolerates sitting, but only in intervals. Break that pattern and the system starts to shift. Maintain that pattern and the system stays balanced. Now think about this moment. You've been sitting, listening to this. If it's been more than 45 minutes, then right now, inside your body, your blood flow is likely slowed and your arteries have slightly constricted. And the solution is incredibly simple. Stand up, walk for a few minutes, let the blood flow again. Because your body doesn't need intensity, it needs consistency. And sometimes the smallest movement is the one that makes the biggest difference.